We are going to go over it. The first group is a Laplace transform. We do it later. We've done this one before, of course. These are all from the quiz, the test 3 that we did. So I start with the, those previous parts. So it's going to be solving the equation by variation of parameter. We give you one. Okay, then solving the equation by using the undetermined coefficients. Okay, and Euler equation and the nonlinear system, nonlinear differential equation. So that would be the kind of 4 questions that we are going to see from the past. The leftover is going to be Laplace transform and its application. Okay, so this is the way we're going to give you the test. We're going to have 13 questions. So far that give you, the first 5 questions. The rest are going to be test 3, that be, quiz 3, test 3, Laplace transform, and all the, solving the equation, the system all together. Okay, there you are. So that's plan. So let's read. That's it. This is your final review. Okay, final review part 1. So start with the question number 2. Question number 2 regarding solving the equation using the method of the variation of the parameter. Okay, solve by the variation of the parameter method. Variation, okay, of parameters method. Okay, we did this one before. Of course, this is the method that we use as you saw it in the case of the system of the equation. In case of the system, we just give you in the form of the matrix form. So that's why we want to check the classic form. So there are 2 here that we did it before, but they are the most popular one. So part 1 is y double prime plus y equal to the secant of x tangent of x. You know that variation of the parameter, you have to use the homogeneous part first. Really equal to 0 to get the general solution of the homogeneous, but then we change the constant into the new function u1 and u2, and then we go from there. So this is it, solution. We are going to solve y double prime plus y equal to 0. Okay, linear equation with the constant coefficient. You need the characteristic one. So the characteristic equation would be r squared plus 1 equal to 0. So that gives you r squared equal to the -1. Okay, so the solutions are going to be complex. R is positive, negative. Okay, positive, negative r. That's it. We pick one of them. R equal to the I, alpha plus beta, remember? Alpha plus beta I. So that gives you alpha equal to 0 and the beta equal to 1. So the solutions are going to be, that's it. You get 2 solutions. Y1 equal to the e to the alpha x cosine of x. So this solution would be simply e to the 0 cosine x, which is cosine x. So that's the first solution. And the second one is e to the alpha x sine of the, sorry, that's a beta x here. Okay, that's a beta x. And this is the beta x. So it's e to the 0 sine of x. So that gives you sine x. Okay, so y1 cosine, y2 sine. So the general solution over here for the homogeneous one is going to be C1. Okay, C1 cosine of x plus C2 sine of x. This is the solution to the complementary homogeneous equation. Any question? Now the YP. So we need to find the YP, the particular solution. The method is variation of the parameter. So the suggestion is x of p, you change this constant into the function. So it's going to be u1 cosine of x plus u2 sine of x. Okay, so we have to find the u1 and the u2. u1 and the u2. And the formula, this is it, u1 is equal to the integral of negative y2 Rx divided by the Wronskian of the y1 and the y2 dx, and the u2 is equal to the integral of y1. Okay, y1 Rx over the Wronskian of the y1 and y2. Identify the Rx, okay, where Rx is going to be non-homogeneous part, that make sure that the coefficient of y dipole prime is 1. Okay, so it's going to be only secant 10 because the coefficient is already 1. So that gives you the secant of x, tangent of x. Now you have to find the Wronskian first, then bring it up, find the u1 and the u2, go back, form the particular solutions. Okay, so we need to find the Wronskian. y1 and y2, and the Wronskian is y1, y2 prime minus y1 prime, y2. Okay, it doesn't matter whichever you start with. Okay, so we go for it. Y1, we pick the y1 to be cosine of x. So the y1 prime would be negative sine. We pick the y2 to be sine x. So y2 prime would be cosine x. Okay, so I'll find the Wronskian. So the Wronskian of y1, y2 is kind of cross multiply here. Get the formula. So that gives you cosine x times cosine x minus these two together is a negative sine x times sine x. Okay, so that gives you cosine square of x plus sine square of x, which is equal to 1. So nothing to worry about the Wronskian. This might be a non-zero number, which is the case. Okay, any question? Now we are ready to go and operate to get the u1. So this is the formula for the u1, and this is the formula for the u2. The Wronskian is 1, so the number with the square, okay, and 2 nice integral give you the final. So we go for the, okay, we go for the u1. So the u1 is equal to integral of negative y2. So y is, I picked the y2 to be equal to the sine, so that give a negative sine x. Okay, times it by Rx. Rx is secant x, tangent x, divided by 1. Then the dx. You simplify it. Secant is 1 over cosine. So sine over cosine would be tangent. Tangent times tangent would be tangent square. So this is going to be negative tangent square. X dx. To take the integral of tangent square, you know that you change it to the secant, and then you're done. So it is going to be negative secant square, tangent square would be secant square of x minus 1 dx. Integral of a secant square would be 10. Integral of 1 would be x. So u1 is equal to, it's going to be minus tangent of x. Okay, minus x. No constant c, because this is a particular solution. So this is going to be negative tan x plus x. So this is going to be your u1. u1 negative tan x plus x. That is u1. Any question? So we just substitute the formula, standard formula that you're going to have it. Okay, that's the best case. Secant square, secant tan. Remember ln x, x ln x. These are the possibilities. And you are going to have 2 of these on the test because you have to do it the same thing for the Cauchy-Euler equation. So you do it twice. Okay, that's a u1. Go on to get the u2. So u2. u2 is the integral of this time y1 Rx over the Wronskian. Okay, dx. So y1. Okay, the y1 is cosine, so that gives you cosine x. Rx is secant tan. secant x tangent x divided by 1 dx. Now, what's this one? Tan x, very good. Secant is 1 over cosine. So cosine times 1 over cosine would be 1. So the result is tangent of x. So this is going to be tan x. What is the integral of a tan? ln secant x, very good. So u2 is ln of the absolute value of secant x. This is going to be u2. Then you have to go back, substitute into the xp or the yp in this case. Sorry, I said xp is the yp because it's it's not the system. Okay, are you done? So I'm going to drop it here. That's yp is going to be, okay, it's going to be u1 cosine plus u2 sine. You have to substitute, and if there is any possibility, simplify. Then you got it. Okay, so I have all of them, u1 negative 10 plus x, and the other one ln of a secant. Okay, I'll go to the next page to form the yp. You simplify if it is possible, otherwise you write xc plus yp, the final. Okay, so there you are, getting that yp, the particular solution. So the yp is equal to u1. Okay, the u1 was negative 10. Okay, negative tangent of x plus x. This is times it by the cosine x. Okay, cosine x plus u2. u2 is ln of the absolute value of a secant x, and this is times it by the sine x. There is no possibility for simplification a little bit, because this is a tangent and the cosine can be simplified. Okay, so there's going to be yp is equal to, you multiply negative tan x times cosine x plus x cosine x, and this would be as is, sine x ln of the absolute value of a secant x. Okay, tangent times cosine. We can simplify tangent is sine over cosine, so that gives you only sine. So yp would be negative sine x plus x cosine x plus sine x ln of the absolute value of a secant x. This is the yp. So the general solution of the equation is going to be y equal to the yc plus yp. With that. Okay, because we simplify, whatever we can. So this is, we write it down. I think you'll find it. Okay, any question? So just refresh your memory regarding this integration and be ready for it. One with the secant, tan. Okay, you did have some previous one. Nice one. So this is with the trigonometric one. It may come with the exponential one. We have one over here to check it. Okay, already part B. Part B, exponential type. Y double prime minus y prime minus 6y equal to the e to the negative x. That's it. Again, the coefficient are going to be constant, because otherwise you cannot solve the homogeneous part. So we are going to solve the homogeneous part first. Solution. That's it. Homogeneous part, y double prime, y prime minus 6y equal to 0. Characteristic equation, r squared minus r minus 6 equal to 0. Factor it. What's the numbers to factor? Negative 3 and positive 2. Good. So we have two solutions, r1 equal to 3 and r2 equal to the negative 2. So the corresponding solutions are going to be y1 is equal to the e to the, remember e to the 3x is the first one, and y2 equal to the e to the negative 2x is the second one. So yc is equal to the c1 e to the 3x plus c2 e to the negative 2x. So this is the solution to the homogeneous group. Again, I write x, this is all y. Okay, that's a yc. yc. Okay, yc is a c1 e to the 3x and c2. No, we need a particular solution. Particular solution is going to be yp. Okay, this can be done also with the undetermined coefficient. And you may not use the method of the variation of the parameter. So you have to follow that. Okay, so this is it. The suggestion is going to be what? Yp is equal to, you change the c1 into the u1 e to the 3x plus u2 e to the negative 2x. And you know the rest. So you identify the Rx. Rx is e to the negative 2x, and we check to make sure that the coefficient of the y double prime is 1. So if it's not going to be 1, remember you have to divide. So we have to find the Wronskian first. Okay, Wronskian of the y1, y2. This is it. So your y1 is e to the 3x. So y1 prime is 3e to the 3x. Okay, y2 is e to the negative 2x. So y2 prime is negative 2e to the negative 2x. Multiply to get the Wronskian. Okay, so the Wronskian, y1, y2, you kind of cross multiply these. So that's going to be e to the 3x times it by negative 2e to the negative 2x minus the other way around 3e to the 3x times it by e to the negative 2x. So the first part give us a negative 2e to the 3x minus 2x x, and minus the second one minus 3e to the, say, 3x minus 2x, the same thing. So the answer would be negative 5e to the x, which is a good one. Okay, it's a non-zero, and we can continue. We know that it's going to be non-zero number. So that's a Wronskian. Okay, we go for the U1. So what's going to be U1? U1 is integral of negative y2. Y2 r of x over the Wronskian, w dx. So what is y2? Y2 is e to the negative 2x, e to the negative 2x times rx. Rx is e to the negative x. Wronskian is a negative 5e to the x. Okay, simplify. Multiply the top, that give e to the negative 3x. Negative will be positive. So this is going to be e to the negative 3x on the top. And that would be 5e to the x. So it's going to be kind of a fifth integral of e to the negative 3x times e to the negative x dx. So it's going to be a fifth integral of e to the negative 4x dx. And this integral, you know that. It's going to be e to the negative 4x, but divided by negative 4 u prime. Okay. Yes. Okay. So the result is going to be negative 1 over 20 e to the negative 4x. So this would be u1. Okay, so u1 is equal to the negative 120 e to the negative 4x. That's u1. Okay, it's exponential one. You didn't get anything with the integration by parts. Sometimes, it's happened. Okay, so that's U1. We could go back, find the U2, put them together. So what is going to be U2? U2 is equal to the integral of y1 Rx Wronskian. Substitute, very similar. Y1 is e to the 3x. And the Rx is e to the negative x. Okay, negative x. And the Wronskian was negative 5 e to the x. So dx. So the top is e to the 3x times e to the negative x, which is the Rx. So that gives e to the 2x. E to the 2x on the top, negative 5 e to the x down the bottom. Dx. So it's going to be a negative 5, negative fifth integral of e to the 2x times e to the negative x dx, which is e to the x. So it's a negative 1/5 integral of e to the x dx. So we get negative 1/5 e to the x. So this would be U2. U2 negative 1/5 e to the x. That's it. After U1 and U2, you go back and form the YP. Okay, any question? Are you ready? So going back, forming the YP. It is U1 and the U2. So this is it. So YP. Okay, YP is equal to, remember it was a U1 e to the, when we pick the video Y1, e to the 3x. We pick the 3x pairs. Okay, e to the 3x plus U2. Okay, U2 to the negative 2x. Okay, solutions was a 3x and the double check. That's it. Okay, now you substitute to simplify it. So this is going to be equal to, we go with the U1. What was the U1? Negative 5, negative 20, yeah? Negative 1 over 20. E to the, let's say E, 4x. Negative 4x. So times it by e to the 3x plus U2. What is U2?
Negative e to the x over 5.
Negative 1/5, yeah? 1/5 e to the negative x or e to the x?
E to the x.
Times it by e to the negative 2x. Okay, you simplify it. So that give a negative 1 over 20 e to the negative x, because negative 4x plus 3x minus 1/5 e to the negative x. Okay, so that's it. We can simplify now because both of them are okay. You get the over here negative x, negative x. Okay, so it's going to be what? Okay, let me just finish it as I did. So this is going to be what? Okay, so negative 5, let me finish it. Negative 5 over 20 e to the negative x. So negative 4 there, e to the negative x. So that give you YP. Yes, what's the question?
You had negative 1/5 e to the negative x. E to the x.
It is e to the x.
Then U1 should be positive. Positive 120 or 120.
U1 is negative 1 over 20 e to the negative 4x. Okay. And the U2 is 1/5 e to the x. Yes. Negative 1/5 e to the x. Yeah. Okay. So it's correct. So that's a YP. So the general solution, y equal to the yc plus yp, and with that. Okay, so this is just to remind you the formulas, and you get one of them to be able to do it. Okay, that's it. So one question on the method of the variation of the parameter. We are going to use it twice, I told you, when we get to the Cauchy-Euler equation. So we get the chance to give you those two possibilities. Okay. So that is topic number 1, variation of the parameter method. Topic number 2 is undetermined coefficient. We give you something short, easy to find. Okay, but we have to check it. So that would be number 3. Okay, number 3, you want to solve the equation, solve by, okay, by the undetermined. Okay, so by undetermined coefficient. Coefficients. Okay, coefficient method. It's going to be, you know, just a short version to be able to test that. So is a y double prime, okay, minus 5y prime plus 4y equal to the 3e to the x. Okay, easy case. Again, you have to solve the, okay, homogeneous one. Again, it's going to be, okay, differential equation with the constant coefficient because you cannot do anything else. Okay, so there you are. You are going to solve this equation, y double prime minus 5y prime plus 4y equal to the 0. Get the complementary homogeneous equation, r squared minus 5r plus 4 equal to the 0. Again, easy to factor. That's the numbers. Minus 4 minus 1 or the other way around. So I pick the R1 to be equal to the 4 and the R2 to be equal to 1. There's no repeated solution. Okay, so the Y1 is simply going to be equal to the e to the 4x. Okay, that's the Y1, and the Y2 is equal to e to the x. Okay, so easily we get the YC, which is going to be C1 e to the 4x plus C2 e to the x. So this is going to be homogeneous. Okay, now to get the YP, we look at what we have on the other side. So we want to find the YP by the undetermined coefficients. So we check that Rx or G of x, it's a 3e to the x. You see, we look at the coefficient. We work with the polynomials. The coefficient is a constant polynomial. So you write the constant polynomial with the unknown coefficient. It's a constant, so the suggestion for the YP would be equal to constant A1, e to the x. But you have to check it to make sure that there is no duplicated term in the YC. It's repeated in the YC. So you have to upgrade it. Yes. Okay. So, thank you. Okay, you have to upgrade it because there is okay, you cannot have a repeated term in the YC. So this is not going to be a good one. So what we have to do is we have to multiply by x to remove the duplication. Okay, now we double check it again. X e to the x is not here. So that's a good one. You know that. You may have to multiply by x squared. If the characteristic equation would give you a repeated solution, then you have to multiply this one by x squared. So be ready for it. Okay, there you are. This is the suggestion. Now we have to find the A1. To find the A1, you have to differentiate it, substitute it into the equation, let the coefficient to be equal to each other to get the other. Okay, so we go for it. So find the derivative. So this is it. First derivative You have to use the product rule. The derivative of the first times second give you a1 e to the x because the derivative of x is 1. Okay, plus the derivative of the second times first, the derivative of e to the x would be e to the x. So that give you a1 x e to the x again. So that's a y prime. And you need y double prime. So the second derivative of the first one is unchanged. The second term, again, you have to apply the product rule again. Derivative of the first time second would be a1, okay, a1 e to the x, and the second first would be a1 x e to the x. You have these common terms or the like terms. So you put them together. So the y double prime would be 2a1 e to the x plus a1 x e to the x. Now I'm going to take this into the, okay, into the non-homogeneous equation over here, simplify it to get your a1. Lots of term are going to be canceled out. And at the end, you end up with one easy term to be able to do it, okay? So go back to this equation. I'm going to substitute here. So I have the y double prime minus 5y prime plus 4y equal to the 3e to the x. So bring them here. So y double prime. So this is going to be your y double prime. Okay, so this is 2a1 e to the x plus a1 x e to the x minus 5y prime. I'm going to multiply right away here. Minus 5, so that give you minus 5a1 e to the x. Again, minus 5a1 x e to the x. So that's a negative minus 5y prime. Plus 4y. This is y. So it's going to be plus 4a1 x e to the x. And this must be equal to the 3e to the x. Those x e to the x must disappear. Okay. So as you can see, this is going to be 1. Okay. And this is going to be 4. You make it into the 5. And you already got the negative 5 here. So they must cancel out. The leftover are going to be like terms. You combine them together and you get your a1. Okay, so the leftover is going to be 2a1 and minus 5a1. So that gives you negative 3. Negative 3a1. Okay, negative 3a1 e to the x is equal to the 3 e to the x. So the coefficient must be equal to each other. So that gives you what? It's a negative 3a1 equal to 3. So a1 will be negative 1. So negative 3a1 is equal to 3. And the a1 is equal to 1. That's it. So you go back, substitute here, you got the yp. So yp is equal to a1 is just 1. So it's going to be equal to the x e to the x. So that would be your particular solution. And the general solution is yc plus yp. And then you're done. Yes, it's good. Which one negative? A1? Oh, okay, thank you. Negative 1. So negative 1, that must be negative x, okay? Yp negative x e to the x. Yp negative x e to the x. So give you something short. Just to check that you remember this method. That's a purpose. Just remind yourself, I remind you again, if there's going to be repeated solution, you may have to upgrade your yp. Otherwise, you know, it's straightforward. That's it. That's a second question. Any question? So far, you get 20 points out of the final. Okay. So ready for the next one? The next one is famous Euler equation. Okay. Euler-Cauchy equation. It's one of those questions that you may see in application problems. Okay. It's particularly in physics. So in this part is the number 4. Euler equation. Okay, that's it. So the Euler, it's Euler-Cauchy equation. Let's call it Euler. equation. You know that the format of this equation is when you say x squared, you must have y double prime. You have this same dimension. X squared y double prime minus 2x, then you have to have the y prime. And the next one, there is no x, so it's y0, which is 1. And is equal to the x cubed ln x, and x must be positive because of the domain of the natural log. Okay, let's call Euler equation. Now you have to solve the homogeneous pairs. You know that it's very similar to the other one that we did. The solution that you're going to have on the other one was e to the rx. In this case, it's going to be x to the r. So you assume that the solution is x to the r. For the homogeneous one, you find the y prime, y double prime, characteristic equation, and you keep going. So there you are. First, we have to solve this equation, homogeneous one. So the homogeneous one would be x squared, y double prime, minus 2xy prime, plus 2y equal to 0. Suggestion for the solution is x to the r. You are going to find the r so that this would be a solution. So we need the y prime, which is r x to the r minus 1. And we need y double prime, which is r times r minus 1, x to the r minus 2. We take this one, substitute here. Okay, all the x's would disappear. You get an equation in terms of the r. You solve for r, and then you come back and you get your solutions. Okay, so if you substitute here, it's going to be, so in the equation, you get x squared r times r minus 1 times x to the, okay, r minus 2. The next one is a negative 2x, y prime, r x to the r minus 1. And the last one is 2x to the r. You can forget about all the x's because all the x's are going to be x to the r. Okay, so these two would be x to the r. You divide by x to the r. These two would be x to the r. And this is x to the r. So the leftover is the characteristic equation. So the leftover is r times r minus 1 from the first part, minus 2r from the second one, and a positive 2 from the last one. Okay, the way we arrange it, always those x's would be disappear. So you solve this equation, you multiply it, r squared minus r minus 2r plus 2 equal to 0. Okay, combine the like terms. R squared minus 3r plus 2 equal to 0. Nice equation. You factor it. What's the number? R minus 2 times r minus 1. So we get two distinct solutions. So the solution is going to be r1 equal to the 2 and r2 equal to 1. Corresponding solutions, y1 x squared, y2 x. Okay, when the solution is not repeated, this is the solution. What is the formula if the solution is repeated?
ln
ln x of what?
r.
No.
No, it's ln x or x to the r of x.
That's it?
Yeah.
If no, you get the first solution. If it's going to be x to the r, so the second one is x to the r ln x. So if the first one is x squared, the second one will be x squared ln x. Okay, so this is the way we do the solution. We're not going to give a complex, because we want to have a non-homogeneous one. So okay, so remind yourself for the second part if it's going to be repeated solution. Okay, so far that's it. YC is going to be C1x squared plus C2x. That is going to be homogeneous one. The point is, we've got to be careful about the particular one or the special one. We have to use the variation of the parameter. This is the only method that we can apply because the coefficients are not constant. So variation of the parameter in order to get the YP. So the YP is missing. In order to get the variation of the parameter, you have to identify the Rx first, and you got to be very careful. It's going to be, okay, so what you do is, on the right side is x cubed ln x, but you have to divide it by the coefficient of the y double prime. You have to normalize it. Otherwise, the formula for the variation of the parameter is not going to be going through. Okay, if you find out that the resultant integral, you cannot do it, probably you missed this one. Okay, so this is it. It's going to be x cubed ln x divided by x squared. So you have to use x ln x when you go to the, okay, you go to your formula. Be careful about this one, because it's always this Euler equation. It starts with the x squared y double prime. Okay, always divide by the x squared. Okay, so we have to form the Wronskian. Okay, we have to get the Wronskian. So start differentiating the solutions. That's it. Y1 equal to the x squared, y1 prime 2x, y2 equal to the x, y2 prime 1, cross multiply to get the Wronskian. So the Wronskian of the y1 and y2 is equal to x squared, okay, minus 2x times x, 2x squared. So the result will be negative x squared. It's a non-zero number because x is a positive number, so nothing to worry about. Okay, so that gives you your Wronskian. Okay, so the Wronskian is negative x squared. Okay, now we are ready to find the U1 and the U2 for the variation of the parameter method. Okay, we go for it. U1. U1 is a negative y2 Rx divided by the Wronskian dx y2. Y2 is x. So that gives me negative x. Rx. Rx is x ln x. X ln x. Wronskian is negative x squared. That's the dx. Okay, on the top, that gives a negative x squared on the top. So it's a negative x squared ln x divided by x squared dx. You simplify it, you end up with the ln x. So it's going to be integral of the ln x dx. You know that you can use integration by parts. If you know the formula in advance, you can apply it.
Can you be positive?
Easy is, yes, it's positive. Thank you. Positive. Okay, if you know the formula in advance, you can do it, but otherwise, it's an easy use substitution. Okay, it's change integration by parts. Okay, u equal to the ln x, dv equal to the tx. So the du is 1 over x dx, and the v is x. So if you put them together, ln x dx is equal to the uv x ln x, okay, minus v du. Okay, that's going to be the case. V du, it's going to be 1 over x times x dx. So it's going to be x ln x minus integral of the dx. So that gives you x ln x minus x. Okay, so the u1, we have the u1. U1 is x ln x minus x. That gives you u1. Okay, any question? So that's u1, you go back and take the u2. With the Wronskian that we have, I need more space. I'll go to the second page to find it. Okay, any question? So we need the y1. Y1 is x squared, and you have over here x ln x divided by x squared. You will end up with the x ln x this time, and you want to find it. Okay, are you done? So going to the next page to get the u2. Okay, so there you are, u2. U2 would be integral of the y1 R of X. Divided by the Wronskian, dx. Okay, there you are. So we go with the y1. Okay, what is the y1? X squared, yeah. X squared. And that's the x ln x. And this is x squared or negative x squared. Negative x squared, okay? So that's the case. So this x squared would be canceled out. There's going to be left over. So it's going to be negative x ln x dx. Again, you need to use the integration by parts to get this one. If you know it, you can write down. So my integration by parts is going to be u ln x. Okay, and this is it. So the v, you have to pick the v to be x. So the du would be 1 over x dx. And the dv would be tx. We put them together. So x ln x dx would be u times v. uv would be x ln x minus v du. V is x. Okay. So that is going to be v is equal to the x. And then vd, I'm not on the right track here because I made a mistake here. That's your dv. Okay, u is ln x. dv is x dx. Okay, you take the u to be ln x. du would be 1 over x dx. You take the dv to be x dx. So we have to find the v. So the v would be x squared over, okay, over 2. That's the case. No. So I have to rewrite this one. Sorry about that. So it's a x ln x dx is equal to u times v. That gives you x squared over 2 ln x. Minus v du. V is x squared over 2. du is 1 over x dx. Should take you back to the x, you get another x squared, then you're done. Okay, so it's equal to the x squared over 2 ln x. And minus these two would cancel out. That give you x half dx again. That make it to the x squared over 4, which is the standard formula for this. Okay, so it's going to be x squared over 4. So this is going to be your u2. Yes.
When we a negative integral at the beginning, so should it be negative?
No, now we apply the negative sign. We apply it now. I find integral of x and x. So I have the negative one, so I change this one to negative. Okay, so it's going to be negative x squared over 2 ln x plus x squared over 4. So that gives you your u2. Okay, so it's unavoidable. You will see the integration by parts most of the time when you go with the Euler equation. Okay, so there you are. You have to find the yp now. So the yp is equal to. Okay, the formula that we did have is this, is the u1. What was the y1? y1 was x squared. And the u2, what was the other one? X. Now substitute simplify. So this is going to be equal to the u1. What was the u1? X ln x minus x. X ln x minus x times x squared. And the u2, negative x squared over 2 ln x plus x squared over 4 times x again. You have to simplify it. So what's going to be the result? X cubed ln x minus x cubed. And over here is going to be minus x cubed over 2 ln x plus x cubed over 4. And we have some combined, black terms to combine together. So this is going to be 1, and this is going to be half. So the result is going to be 1/2. Okay, 1/2 x cubed ln x. And this is the -1 and a positive quarter. So the result would be 3/4. Okay, 3/4 of x cubed. Negative 3/4. Yeah, negative because of the -1. Thank you. So that gives you the yp. Okay, so the final answer, y equal to the yc plus yp. Okay, so that's the Cauchy-Euler equation that we're going to have. Okay, so that make it into question number 4 or number 3 in this case. Okay, any question? Let's do one more, then give you a break. So the last one from the first part is a nonlinear equation. Remember, nonlinear equation, you reduce the order, you get into the those U substitution that we use. Again, they are going to be used in application problems. So that's why we are going to check it. There are 2 possibilities. We give only one of them. 1 out of 2. Remember, this is the kind of the equation. It's a second order equation. It's not linear. But the case is that one of the variable, x or y, is going to be missing. Okay, that's the condition for these equations. Then we can use the U substitution to take care of. Okay, so 2 cases, nonlinear system. So that would be question number 5 on the review. Okay, solve each equation. It's a nonlinear equation. Solve each, we give you the hint. Okay, each non-linear equation. Just to remind you what's going on. Okay, going for case 1. The case 1 is this one. The case 1 is y double prime plus, give me something short. That's it. You see, this is a nonlinear equation, and in this equation, x is missing. That's a type 2 when you do it. So when x is missing, you have to change the derivative from the derivative respect to the x to the derivative respect to the y to be able to do it. Because there is no x. We talk about the du dx. Okay, so this is how we're going to do it. The substitution. The substitution method is going to be u is equal to the y prime. Remember when you say y prime, it's a dy dx. Now, in order to get the u prime, use the chain rule. Remember, we use the chain rule and we change it into the u du dy. So you must remember the way we are going to do this one, you know that this is the second derivative. So second derivative with respect to the y prime, we use the chain rule. Y is a function of u is a function of x. We end up with this one. Let's make sure that you have the proper substitution for this case. Now go back, substitute. Your equation would be an equation in terms of the u and y. Then you can do it. So if you go back and substitute, you get the y. Okay, then, sorry, that's, I made a mistake over here. This is going to be, in fact, okay, let me just write it in this format. That's u prime u, it's going to be y double prime. So y double prime is going to be u du dy. See, that's the way you do it. Because u is already y prime, you differentiate both sides. Okay, you differentiate both sides. So that gives you u prime equal to the y double prime. But the u prime, you change it into the, okay, use the chain rule, you change it to the u du dy. Now you are going to take these 2 into your equation. So you have the y, then you get the y double prime. Y double prime would be u times du dy. Then plus y prime squared is the u squared equal to the 0. You see this equation? It's an equation in terms of y and u. So when you differentiate, you see, you know what's going on. There's no x there. That's why you have to create that dy to be able to do this problem. Okay, so we have the u squared. You can divide by u, because we assume that the u is not 0. Because if u is 0, y prime 0, y would be a constant. Okay, so we can divide by u. So that give you y du dy plus u equal to the 0. Now it's an easy equation to solve. Any suggestion? How can we solve this one? That's it, yes. Separable variable or separated variable, yeah. Separable variable, you separate the d, you know that you put the u and the du together, y and the dy together to be able to do it. So this is how we can arrange it. Okay, you can cross multiply, then take care of it. It's a negative u dy. So put the u together and the du, y, and the dy. So it's going to be du over u. And on the other side would be negative dy over y. You can get this negative in one of those. It doesn't matter. Okay. Now it's a separable variable. You integrate. Okay, if you integrate both sides, this is it. So this would be ln u, and this would be minus ln y. Assume that it's positive. Okay, then you get a constant c. Then we call it c1. Remember, it's the first time. You better simplify. You have to find the u to be able to go on for the second part. So different way to simplify this one, we can use the definition of the ln. So u would be e to the negative ln y plus c1. Okay, and you break this one. You break it into the e to the negative ln of y times it by e to the c1. E to the negative ln y. You put this negative up. So that give you u equal to the e to the ln of 1 over y. And this is times e to the c1. You can call it c1 again, or call it c2. It doesn't matter. It's a constant. Okay, so I'm calling it c1 again, or c2. So e to the ln of 1 over y, you are going to lose the ln. It's the 1 over y, okay, times that c1. c1 is going to be c1 over y. Any question? So we have to do this, simplification to be able to get through it. Yes. That's it. That would be better. Yeah. Yeah, that would be quick. But since there is a negative sign here, yeah, you can call it ln of c1. You see, the other method is this one. You have the ln of u equal to negative ln of y. You call this one ln of c1. Okay. Now this is going to be ln of u. This is a difference of 2 ln. The difference, we change it to the quotient, remember? So it's going to be ln of c1 over y. Use one-to-one property of the ln. U would be c1 over y. So two different methods. You arrive at the same one. So that's quick, ln c1. You call it ln c1 and you put them together. Okay. Any question? You're not done? You're looking for the y. Okay, so that's going to be the first part. Now you have to change the u into the, u prime, u into the y prime. So y equal to the y prime, u equal to the y prime. So that gives you y prime equal to the c1y. Now this is a question of the first order. We can do it. You change the y prime into the dy dx and continue. So it's going to be dy dx equal to the c1y. Again, a separable variable. Okay, put them together. So if you put them together, that gives you y dy equal to the c1 dx. Now integrate y dy equal to the integral of c1 dx. So y dy, that gives you y squared over 2. Okay, and over here, you get c1x. cross multiply plus C2, of course, plus C2. That's it. We can multiply by 2. So y squared equal to the 2C1x plus 2C2. Okay. You can save it as is, or you can call them C1 and C2 again. It doesn't matter. Okay. So this is going to be the final answer. Okay. We're not going to take the y, take it's going to plus or minus. We leave it as is. In implicit form, we call it. We get the final answer. Okay, that's it. That's going to be the type 2. I give you a break, we come back. The other part, that is easier when the y is missing. As soon as you get to x, you can do it. Just remind you how you take care of the blocking. I know. 12. 13. Yeah, I think it's 125, yeah, or 110. I have to check it. I'm not sure.
We're trying to figure that out.
I didn't know that.
Yeah, check the syllabus.
The finals 30% of the grade?
Huh?
The finals 30% of the grade?
Why not? I used to give 50%. 15 problem, we do that university. So officially, your final must be more than 25%. That's very important. The only official exam is the final. Practically.
How many questions are going to be well?
Many.
200.
How many points, you were talking?
Yeah.
How many points in that?
400 total. So
No, the final. 120, so it's going to be up to the 12.
And you're gonna drop one like usual or?
Yeah.
Yeah.
If we give you 12, you answer it.
Okay.
That's what we probably do this. Because it takes time. Yeah, I gave this one last semester at Mercosta. I give them 16 questions. And they will answer 15. But I gave them 3 hours to do it. Okay? So it takes time.
Do you have the notes from Monday's class?
No,
No.
because I ran out of paper.
Oh,
So this, the one that I have is a new one.
oh, no, okay. Are you on the? No.
You can ask them out for the upload of this. So I don't have to.
You know what I'm saying?
Otherwise, you can email me over the weekend.
I think I emailed you to see if I can put one election.
Yeah, I posted. I posted recording. I told you, I think I emailed you back. The recording so good.
Oh.
You requested.
Do you want me? Oh,
Yeah, when I'm done with this section, then I post the notes.
It's ridiculous.
So you're telling me I could still potentially get an A in this class with a 30% final? I never calculated it, but I just did right now, and I think I can.
Okay, there we are. You done, right?
Okay, help to, we had finding the out that first part of the final, so the one. 40% rate.
Yeah, I mean, the final is over. No, so sometimes some of the students will tell me that, oh, or it's not handled it. Do I have to come to the final? I said, well, I'm talking about. If you don't come to the final, you don't have. Not come to the final. Then I said, somebody told me that I don't need to take the final. You don't say this part. This is one enough. I'm going to investigate you and your instructor. You can't read. I had a student, she was so hard-headed. She got all the 100. He said, I don't need to come to the final. I said, okay, you don't come to the final, then we will see. She didn't come to the final. I give her an F. And I got several, get up the apartment, etc. They asked me to wake up exam whatever. I said, no, it's on the syllabus. It's on the syllabus. We arrange it so that you have to take the final. Get a C in this class. You don't take the final. Consider. No, I got the 500%. Don't come to the final. Okay. You can't give me an F. It's okay. You don't come to the final. And then you will find out. You can't say that.
Right.
I have to follow the syllabus. If you can't do it. I have to follow the syllabus. So, but eventually I agree not to do that. Fine. That's very nice. In a few days. No,
To make the harder final.
because, that was, I got a number of my colleagues in the department, etc. I was very interested. I asked if you come for the final. You get a make. Yeah, every day. As soon as we start with this, there was a fire alarm, these. I didn't know that. So I have to.
You just went up there and.
So I just have other appointments, to do,
How did she do?
Should
How
we,
to be better?
should we, should make them all like long.
They keep
The one-
repeating it, and every time you say something, yeah, but this is gonna be like this.
Well, it'd be like 3 levels of integration by parts.
No,
Or more.
Not bad, talking about
so this is, level of the syllabus, if something happens. So somebody can see the color or see, that's why you have to make sure you know everything you can want. That's not. I mean, at least you come to the time and say hello. And like it's done, then I follow, nobody can argue. You have to say. Check me. So, at least you don't come. Don't do it. Because we're not there.
It's like, there's a blank piece of paper. Yeah, that's like.
Then you know what's talking about. Whoever emailed the professor, very cheap, because I was giving your
I asked the students, he got a surgery.
Did you?
The surgery is that, right, see what fight.
Yeah.
You calculate it.
I was on my way to the
And I was from university. Last night, because we were supposed to take every fight. Calculus green.
Yeah, so they,
And do the look of the surgery.
You the-
And when he told me to bless the 15 buttons.
so the.
And he said, no, I'd rather take this one before that surgery.
I was at the.
Why? You have to do a paper boards and he's like, and then-
That. And he gave me.
Can I drop it? No, can I use it? Yeah, I said you have to live, you know, in the range of the time, right?
Yeah, me too.
That's it, you can do it, you know. I just catching is that's that. Look, I mean, I told you.
For many of you.
No, I don't hear that.
What?
Anyway, we get it soon.
Like over 3 cents. Count one, count two.
Take the point.
And now- Yeah, like, we have been over here. That's it, I'm not.
Auditing costs on this.
Okay, we go for the type 2, second part. So that's number 5, part B. Okay, that's going to be the 5B. The equation that we got to solve is this one. Y prime, Y double prime. Okay, minus X equal to the 0. This time you have initial condition. Y of 1 equal to 2 and Y prime of 1 equal to 1. Okay. It's a nonlinear equation. As you can see, Y is missing. Y is missing. The direct substitution of the U equal to the Y prime and U prime equal to the Y double prime will do it for you when the X is there. Okay. So that's it. You take the U to be Y prime. U prime is just simply Y double prime. You substitute, so that give you U prime minus, okay, U prime minus X equal to the 0. See, then easy equation to solve. You change the U prime into the du dx this time, and would be separable equation, we can take care of it. Okay, so it's going to be U du dx minus X equal to the 0. Move it to the other side to make it separable. Okay, you can cross multiply, then you put them together. That's it. Integrate U du equal to the X dx. So that gives you U squared over 2, X squared over 2 plus the C1. You can multiply everything by 2, simplify it. So that gives you U squared equal to the X squared plus 2C1. You can call it C1 again. So that's going to be U squared equal to the X1 plus C1. Okay. Now you substitute for U, but apply the initial condition now to take care of the C1. Okay, so this is going to be Y prime squared. Okay, I take the U is Y prime here. Okay, equal to the X squared plus C1. Now apply the initial condition. So the initial condition is the following. X is 1, Y is 2, Y prime is 1. Substitute. So if you substitute, this give you 1. It's going to be 1 and C1. So C1 would be 0. That would be very helpful. Very helpful to apply it now. You're not going to wait for it. Okay. So the result of the equation would be y prime squared equal to the x squared. So, take the square root, and then the rest is just a straightforward problem. Okay, we take a positive root, y prime equal to the x. And y prime is dy dx equal to the x. So the dy equal to the x dx. And if you integrate, that give you the result right away. Okay, so that give you y equal to the x squared over 2 plus c2. You apply the initial condition again. X is equal to 1, y is equal to 2. So we apply this condition, end up with 2 equal to 1/2. I applied here. 2 equal to the 1/2 plus c2. So c2 would be 2 minus 1/2, which is a 3. So the final answer, the particular solution is x squared over 2 and plus, plus 3. That give you the final answer. Okay, so if you need more, you go back and check your probably test 2. This is where we talk about these nonlinear equations. Okay, it's the 2 cases, but we give only one of them. Okay, one of them, and we give you something short because these things, that it can be resulted in very complicated equation related to it. Okay, that's it. Yes, what's the question?
When you first applied the condition, on the first answer, the y prime squared is the first C1.
Yes,
How did you get 1 equals 1 C1?
I substitute.
Where did you get the 1 from?
I substitute. Okay, you have it. That.
Yeah.
X is 1, y is y prime. Okay. Any question? So apply that initial condition as soon as possible. Okay, to get simplify it. So otherwise, it would be a difficult problem to go. Okay, so that's it. This is all the initial one from the previous parts that take you to the Laplace transform right away. Okay, so from now on, it's going to be just test 3. Okay, whatever we did on test 3 is going to be coming here again. Okay, so it would be taking the Laplace. You see, that's it. We are not going to give you Laplace inverse directly because you're going to do that one quite a lot for us when you solve the equation. But they give you one question, finding the Laplace transform. And that would be involved with those formulas that we have. Remember, you need a step function, derivative, translation, type 1, type 2. It's one question, but it's going to be a couple of these together. Okay, so I just remind you again, this is going to be your first question on the Laplace. So that takes us to the number 1. Okay, find the Laplace transform of this function. Find the Laplace transform. Laplace transform of each function. Okay, all those 3 famous theorems that we have, translation, and then regarding unit step function. We put them together. There you are, the first one. F of t equal to e to the negative 2t cosine of the 4t. Remember the way we do this one? We are going to do the Laplace of the cosine of the 4t first. Because of the e to the at, if you have the e to the at, you transform it. Transform the s into the s minus a. Okay, so this is the way we do it. Solution. That's it. You are going to find, this is going to be Laplace of f of t is going to be equal to what? Equal to the Laplace of cosine of the 4t. But when you change the s into the s plus 2, transform, that translation equation. Okay, there you are. So the Laplace of the cosine of the 4t is s over s squared plus 16. And we have to change the s into the s plus 2. So it's going to be s plus 2 on the top. S plus 2 is square plus 16 down the bottom. We accept this one as a final answer. Okay, so the Laplace of f of t is going to be s plus 2 squared plus 16. Done. That's case 1. Using the translation theorem, the first translation theorem, remember? Any question? The next one regarding the unit step function, UCT. What's the Laplace of UCT? E to the negative CS over S. There you are. So part B. Part B, the function is f of t equal to t cubed plus 2u2t minus 5 u40. See? So this is the solution. Laplace of f of t is equal to the Laplace of the t cube. Okay, let me write it down so you know that it's going to be Laplace of the t cube plus 2 Laplace of the u2t minus 5. You can do it right away, we accept it. Laplace of the u5t. So Laplace of the t cube, you know, it's going to be n factorial. It's going to be 3 factorial over s to the n plus 1. So it's going to be 3 factorial over s4, the formula that we have. So it's going to be 2 unit the step function base 2 e to the negative 2s over s unit the step function base 5. So it's going to be e to the negative 5s over s. Sorry?
C1 from 4 to 5.
What is that?
You change it from U4.
Sorry. Sorry, what is the base?
4.
Base is 4. Okay, so that's a 4. So this will be e to the negative 4, yes? So the final answer is what? 3 factorial. 3 factorial 6 s to the 4 plus 2 e to the negative 2s over s minus 5 e to the negative 4s s. The final answer. Okay, we accept this type of answer that we've done. So that will give you the, okay, the unit step function. Remind yourself the formulas that you need to know in case. Now, you did this one on the test, the next one. So we may give you this one again. F of t equal to the t squared, sine of 2t. Remember the power of the t, we can do it by the derivative. If you have a t, f of t, you find the Laplace of f, it's going to be f prime. If you have a t squared, you have to go for the second derivative. So this is how we're going to do it. You have to find the Laplace of the sine of the 2t first, then differentiate. So the Laplace of sine of 2t is equal to a2 over s squared plus 4. That's the Laplace of the sine of 2t. We call it fs. Now the one that we are interested in is going to be, you see, you have the t squared here. So the t squared will be f double prime. Okay, so this means the Laplace of t squared sine of the 2t is going to be negative 1 squared f double prime of this, which is going to be f double prime of this. So we're going to differentiate f of s twice and then do that. Okay, for the first derivative, use the quotient rule. If the top times the bottom would be 0, bottom top, negative 4s divided by s squared plus 4 all squared. You better rewrite it then differentiate it again. Okay, avoid the quotient rule. You go with the product rule. So f double prime of s, derivative of the first times second, minus 4 times s squared plus 4 to the negative 2. Second first, you bring the negative 2 down, negative 2 times the negative 4s would be 8s. 1 down, s squared plus 4 to the negative 3 times u prime, which is a 2s. Okay, 2s times 8s, that give you, so that would be negative 4, s squared plus 4 to the negative 2 plus 16 s squared times s squared plus 4, everything to the negative 3, the final answer. You can rewrite it if you like, but you don't have to simplify it. Okay, put them together. It takes time and we are happy about it. Okay, so that remind you that you may have to use the, okay, this famous theorem or the F prime that we have. Okay, so just prepare those formula for yourself, okay, and then you do it. But just going to be one question, 2 parts. So that is the case for the sine of the 2t. You have another one for the cosine. It's a t cosine. The derivative is straightforward. Let's do that one too to finish it. Any question? You're done with this one? So we go to the part D, or this is must be part D. We call it E. So this is going to be the part D. The function in question is t cosine. Since it's the t, you need only the first derivative. Okay, so you find the Laplace of a cosine t first, which is s over s squared plus 1. So you call it f of s. And then you go for the Laplace of t cosine t. You know that this is going to be negative 1 times f prime, which is going to be negative f prime of s. The first derivative is going to be negative. Now you apply the quotient rule to get this one. If of the top times bottom, so it's going to be negative. If of the top times bottom would be s squared plus 1. The bottom times top, 2s times s, divided by s squared plus 1, all squared. You simplify it on the top, and then you're done. So it's going to be s squared plus 1 minus 2s squared minus 2s squared over s squared plus 1 all squared. And then if you combine the like terms, that give you that famous formula that I used the other day. 1 minus s squared plus 1 all squared. The final answer. Okay, they are popular problem, you know, for future.
Negative.
I missed that negative. Negative. Okay. So I can apply to the top. This is it. Negative 1 plus s squared over s squared plus 1 all squared. And this is going to be used in solving the equation. There was one equation that we discussed it only once. That was Bessel equation, if you remember. There was for the variation of the parameter, was very complicated one. The solution was a type of sine of 1 over x, cosine of 1 over x. If you want to do those type of problems by using the Laplace transform, the coefficients are not constant. You get something like x, y double prime, x squared, y double prime. The only way that you can do those type of equation is these ideas, to put them together. But, you know, you have different methods to do it. So it's nice to know. Okay, that's going to be part D. Okay, the part E was the one on the test that we give you. Okay, and we will back up all of them. So we finish this one. That is a piecewise defined function. Remember, you did this one twice. It's a cosine of t when t is less than or equal to 1. We want to use that second translation theorem that we have. T minus 1 cosine t when the t is greater than or equal to 1. Okay, you know that we change it into the unit step function, and then we take the Laplace. So we can take out the cosine t. We change it into the format which is popular. It's going to be cosine t. Okay, so the leftover is going to be 0 on the top. And this is going to be t minus 1. Okay, and we take it this t minus 1. So f of t is going to be cosine of t plus t minus 1. Okay, now what's the function? Because the leftover is going to be 0, 1. You see that would be 0, 1. It's a 0, 1 when t is less than 1, greater than or equal to 1. And you know that this is going to be unit step function at the base 1. So it's going to be f of t equal to the cosine of t plus t minus 1. But u1t. That's the one that you got on your last test. Now we find the Laplace transform right away. Cosine of t is easy, and the other one, you just to see remember that's the second translation theorem. u1t, t minus 1. Okay, so what's going to be Laplace of f of t? It's going to be Laplace of the first one. Laplace of cosine is s over s squared plus 1. The second one, because of the u1t, remember you are going to have a u to the, okay, u to the negative s. And the rest, remember, the function is t minus 1. But you have to find the Laplace of t. Okay, x minus c u c t. That was the formula that we did have for this one. Okay, so the final answer is going to be s over s squared plus 1. What is the Laplace of the t? 1 over t squared, s squared, s squared. So that gives you the Laplace transform. Yeah. It's a nice problem because you have to know. You have to organize it nicely, change it to the unit step function, and then you go for it. Okay, so as you can see, we have all the possibilities for this type of problems, but we put a couple of them together and we give you one question from this section. Okay, so this is the definition of the Laplace transform. Okay, any question? No Laplace inverse for this case. Yes, Laplace. No application of the Laplace transform. The first application is applied to the equations. Okay, we give two equations to solve, applying the Laplace transform. One equation that's going to be straightforward, no unit, step function, etc. And the other one is going to be more involved. We go with this unit step function. Okay, it takes a little bit more time. So that's it. Number 6. We did all of them, I think, but I just check one of them for you, or one or two, just to remind you. So you want to use Laplace transform? Use the Laplace transform. Laplace transform to solve equation, to solve this equation. Okay, the first one and the second one are going to be just straightforward. Okay, so we may go with the second one. It's going to be a little bit more involved. Okay, so the first one is the one that you got on the test. Y double prime minus y prime minus 6 equal to 0. That was then we check it. So I'm going to check the second one. Okay, the second one is y double prime minus 4y plus 4y. Y must be a misprint here. This must be y prime. Okay, y double prime minus 4y prime plus 4y equal to 0. With the initial conditions of the y0 equal to 1 and the y prime of 0 also equal to 1. Okay, that takes a little bit more time to do it. Probably you need to use translation theorem. Okay, you know that how we're going to do it. We're going to check replace the y by f of t, find the Laplace of those derivatives, change it into the algebraic equation with the Laplace transform, and at the end, we find the Laplace inverse. Okay, so there you are. We take the y to be f of t. So the initial condition would be f of 0 equal to 1 and f prime of 0 equal to 1. Okay, go take the Laplace transform of these. So it would be the Laplace of f double prime of t minus 4 Laplace of f prime of t, okay, plus 4 Laplace of f of t equal to the 0. Now bring the formula for the Laplace of the derivative of the functions. We know that for f double prime is going to be s squared. Okay, s squared Laplace of f of t. Then we reduce the power of the s, we multiply by f of 0, f prime of 0, f double prime of 0 as it's needed. So you lower the power, so that you will negative s minus s, f of 0. You lower the power again, you get a constant, and this is going to be minus f prime of 0. If you start with the f double prime, you must end with 1 dot f prime. Okay, so that's the first part. The second part, you repeat this one again, minus 4 times it by is f prime, so it's going to be s Laplace of f of t. Lower the power of the s, so you're going to have f of 0. Again, you need those formulas. You can bring those formula for the Laplace of the derivative of the functions, okay? So that's the second part, and the last part would be plus 4 Laplace of f of t equal to 0. Okay, carefully you apply these formulas. Now we're going to apply the condition that we have. Initial condition, f of 0 equal to 1. So this is 1. F prime of 0 equal to 1. And f of 0 equal to 1. So apply this condition. So you are going to arrive at s squared Laplace of f of t minus s minus 1 minus 4s Laplace of f of t. Okay, and plus 4 equal to, okay, plus 4 Laplace of f of t equal to the 0. Okay, so I applied the initial condition. Initial condition, both of them are 1s. Now you have to factor out the Laplace of f of t and arrive at the characteristic equation of the homogeneous equation. Okay, so there you are. 1, 2, 3. If you take out take care of the Laplace of f of t, that give you s squared minus 4s, okay, plus 4 times Laplace of f of t. This means we are safe because we got this, the coefficient must be characteristic equation. The leftover, it's going to be minus s, this is minus 1 and plus 4 that give a positive 3, nothing else. Okay, negative s and plus 3. Okay, move it to the other side. So that gives s squared minus 4s plus 4. Laplace of f of t. Other side, that gives s minus 3. Okay, so that gives us s minus 3. So what we are going to do is we divide. So the Laplace of f of t would be equal to s minus 3 over s squared minus 4s plus 4. Okay, so this is going to be the case. I haven't missed anything on this one. S negative s minus 1. And everything is all right. Okay, There you are. You have to find the Laplace inverse of s minus 3 over s squared minus 4 plus s. So what we can do for this is going to be the denominator would be a perfect square. It's going to be s minus 2 squared. Then again, I have a dot about this one.
Separate the top, so we have this minus 2 minus 1 on the top. And then we can do s minus 2.
No, it's going to be s. No, the bottom one is a perfect square.
Yeah.
So you can't do that one. Okay. So I don't remember the way we take care of this one. I think everything is all right. It's a Laplace inverse of, I want to avoid those derivatives that I did the other night. S minus 4s plus 4. So the one option is to just break it down, and then we can do the, okay, you may have to do it by the derivative that we're going to have, okay? So the way we are going to do it, this is s minus 3 over s squared minus 4s plus 4. So that would be what? And that would be s minus 3 on the top. Down the bottom would be s minus 2 all squared. You see? That is what you're going to have twice up the first time second. Okay. Now to get this one, we change s minus 3 to the s minus 2 minus 1, then we'll be able to do it. Okay. So it's going to be s minus 2 minus 1. When you have this repeated solution, this is going to be the case. Okay, so it's going to be s minus 2 over s minus 2 squared, the first one, minus 1 over s minus 2 squared. So you lose the first one, is going to be what? So this gives you 1 over s minus 2, and that gives you 1 over s minus 2 squared. We are going to use the translation theorem to get the second one. The first one is easy. The first one is simply what? Is 1 over s minus 2 is going to be e to the 2t. That's the second one. For the second one, you can call s minus 2 to be s. It's 1 over s squared. When we get the 1 over s squared, remember the translation I'm going to have is going to be e to the, you find the t. Okay, let's see. So this is it. I give a Laplace inverse of both of them. It's a very nice problem, okay, when the coefficient is perfect square. Okay, there you are. Laplace of 1 over s minus 2, that give you e to the 2t. That's the first one. Okay, that's the first one. The second one, the Laplace inverse of 1 over s minus 2 squared. Okay, we go with the 1 over s squared first. 1 over s squared would be what? Would be Laplace of t. Okay, would be t, then we have to multiply by e to the 2t. Second one. Remember, it's simply a homogeneous equation, you know, to start with at the beginning with the repeated solution. So the first solution is e to the 2t, so the second one would be t times e to the 2t. So that's why these type of equations would make it different. You have to know this in advance to be able to move around to get these numbers. Otherwise, those powers would be complicated. So it's nice to know. Okay, we put them together, and eventually we find the solution of the equation. So f of t is equal to the e to the 2t minus t e to the 2t. Exactly, if you solve the equation, you will get the same one. Okay, that's the best case for the first group. Yes, let's go, John.
We use partial fraction decomposition.
You can't do it for this one. Why not? Because you can't do it. That won't give you anything. So what are you going to gain from the partial fraction?
I was gonna do S minus 3 on the top. Then I'm gonna do A over S minus 2 plus B over S minus 2 squared, and then set them equal to each other and make this. I'm being serious, why wouldn't it work?
Do it. If you like to do that one method, do it.
Would it work?
May work or may not. Okay, it takes time. To do this problem is nicely designed for you to do these type of problems. We do know type of function really if you see that your difficulty is going to be the denominator. If you want to do the partial fraction, is a repeated factor. When it's a repeated factor, you have to have two fractions. One for the t squared minus 4t plus 4, and then another one for t squared minus 4t plus 2 for a square. On the top of each, you have to put a linear equation. A1, T1, A2, A2, dot. It takes quite a while. And eventually, you see, the difficulty is you are not going to be able to take care of that square that you needed. Because that square can be done if you can change it to the translation one. You see the way we did it? See that S minus C squared. So we try, you do that one if you have to. You do that one only if you are not going to get the repeated factor down the denominator. Otherwise, there is not going to be no use. If you do it, you come back again to this one. Okay, so that's, you have to look for you see, you have a look at the given equation. If you solve this equation in the ordinary method, you have a repeated solution, you know that. So as soon as you get the repeated solution, they give you the hint that when you go to the Laplace transform, you have to use the translation one. Okay, so that was the point about this problem that we have to know. Okay, I think maybe that's enough. Yes, we can do more, or we leave it for we have the Monday to be able to do it.
Are we just gonna be doing more with the number?
We have to do the rest, the main one. Yeah, we can do more. It's 2 hours. The main one is here, system. You see, what we have to do, the other question are going to be what? You should be able one system of the equation using the Laplace transform. That's one. You don't like it, but we give you one. Okay, then we go to the system with the eigenvalues. You have homogeneous and non-homogeneous. For the homogeneous one, we have 3 cases, remember? Distinct eigenvalues, complex, and the repeated. We give you just one of these 3, because we're going to check it again. So that would be 1. Then that will take us to the, what's this? Non-homogeneous one. We give 2 non-homogeneous. One that you have to use the variation of the parameter. The other one that you have to use the coefficient of the undetermined coefficients. So this is the we're going to finish it. Okay, so if you add them together, you should get something like 10 or 11 questions that we promise. So we can drop one of the question, okay? So you can decide which one are going to drop in advance. Okay, that's one. Okay, I think that would be enough. We can be able to do the rest on Monday. Over the weekend, I will post that one that I promised you, your last 5 points. I arranged it as design of the number of the problems that are going to be on the final. So you can get practice really before the final. So if I decided to give you 11 questions, I give you 11 questions. I have a couple of good one for you. And I won't get time to explain. So I put it over there. So great. That's one. Okay, have a good one. See you then. Hey, Angel, I didn't have the board. When you talk about it, I'm outside of my home. Right. Have a look at it. I can show you right now. Close this one.